All right, welcome everyone to this week's webinar. I'm Paul Lefevre, the Xojo Developer Evangelist, and this week we're going to continue our discussion of object-oriented programming with our Part 2 session. Part 1 was back in June, and now we're already at the end of July, so it's time for Part 2. I want to encourage you to ask questions as I'm talking. I have the question window up here on my other screen, so I'll be able to see them, and we'll answer them when appropriate. And without further ado, let's get started. All right, if I can get this to go to the right screen. All right. First thing we're going to talk about are constructors and destructors. Now, both of these are optional, and they're essentially special methods that allow you to initialize your classes when they're created, or deinitialize, if you will, when the class goes away, when it goes out of scope, when it's cleaned up. You do this by having a special method on your class that has the name, surprisingly, called constructor. And this method is called whenever the new keyword is used to create a new instance of your class. And there are a few things to remember when you're using constructors with UI controls. We'll look at an example momentarily on how you use a constructor in general. The one thing I want to point out about UI controls is that if you do put a constructor on a UI control, it's very important that you call the super constructor. Now, this is because all the UI controls inherit from another control, the rect control, actually. And the inherited class, the superclass of all the controls, does some work in its constructor. So if you implement your own constructor, but then don't call the superconstructor, that little framework initialization code that needs to happen won't get run, and your stuff isn't going to work the way you expect. So let's take a look here at a constructor example. Now, the typical way that you've probably seen new classes created is simply by using the new person, is what our class is here. And you can see we're creating a new person, new instance of that. We're storing that in the P1 variable. And then this is just setting the properties for the class, nothing too unusual there. But you can add your own new constructors, add code to the default constructor to do initialization, whatever you think is appropriate for the class you're designing. So this particular thing, in the next example here, I've added an additional constructor that allows you to supply in the name right when you create it. And this constructor will populate the properties for us. So you can see when you run it, we'll get the two entries appear in our list box here, the one where we manually set the properties and one where the constructor did it for us. Let's see what that constructor looks like. So you can see you just had a method and you call it constructor. This particular class has two on it. It has the default one that's just constructor with no parameters. This doesn't actually have any code in it. It's not doing any initialization. This is a new one here, and this has some parameters, the first name and the last name as strings, and it's simply assigning the properties to those values that were passed into the constructor. So that's how you're doing the initialization. And like with any other method, you can have any number of constructors that are overloaded however you want with different parameters, different types, that sort of thing. And depending on your class, it can be very handy to have these little convenient ways to sometimes quickly populate commonly used items in your class rather than forcing all the properties to be set manually after the instance is created. I don't specifically have an example here of a destructor, and that is because you rarely are going to need to use destructors in your normal Xojo programming. You'd add a destructor the same way. You'd add a new method and you call it destructor. But because of the way Xojo manages its memory, which we'll be talking about in a moment, you generally are not going to have to worry about that. The only time you're going to want to put something in a constructor really is if you're interfacing with the operating system in some way and you're accessing API calls that need to be manually cleaned up. And you may need to put something in your destructor to handle that cleanup for you because it's not something that Xojo is doing. But again, it's a very rare situation. All right, well, speaking of memory management, it's important to think about this a little bit when you're dealing with classes, because each time you create a new class, you're essentially creating something that's taking up more memory. Now, Xojo uses a technique for managing memory called reference counting. You may have heard this also referred to as automated reference counting, or ARC, and that's probably because it was recently added to Objective-C a few years ago by Apple. Before that, people primarily had to manage all their memory when they were coding in Objective-C. They had to manage all that manually themselves. And reference counting is really, really nice because it is fast. It's also very efficient. And essentially all reference counting is that each time you create a new instance of a class, the reference is increased, and each time that reference goes out of scope, the reference is decreased. When the reference gets to 0, the memory is released. It's as simple as that. And it's all automatic for you, so you don't have to be specifically tracking what is being allocated from memory and releasing it and all that stuff that is not really much fun when you're programming. However, in the case with reference counting, you do have to watch out for circular references. And this is the situation where you have an instance that such as A refers to B, but B also refers to A. So the two items are both referring to each other. So there's no good way for the reference to get down to 0. So here's a picture of how this might work. You've got a P1 here on the left, which is a variable that's pointing to an instance of a parent class. It can be anything, really. And the parent class points to a child class. But the child class also points back to its parent. So you've got this double situation here where the parent and the child each refer to themselves. So you can see in this case, the parent has a reference count of 2. The P1 variable is the first reference, and the child referring back to the parent is the second reference. The child has a single reference count because just the parent is referring to it. So that's what the reference counts look like behind the scenes. Now, if you were just to let P1 go out of scope or set it to nil, that's going to clear up one of the references for parent. So its reference count is going to drop down to 1. Child's going to remain with its reference count at 1. So now you have these two objects that remain in memory that are pointing to each other, but you no longer have your own reference to them. So they're kind of stuck in limbo, and this is referred to as a memory leak. Now this memory will be released when your app quits, but as long as your app is running, these objects now remain in memory, and you no longer have a way to access them. So they're leaking. Your app is going to continue to use up more and more memory as it runs if this situation is repeated. Now you can solve this pretty simply if you know that you're doing it. And let's look at the next picture here. Just by adding an extra step. So instead, the first thing you want to do to solve this and to release the memory appropriately is to clear the child off of the parent so that its reference back to the parent goes away. And then when you do that, you end up with, you still have your reference to the parent, so the parent's reference count now drops down to 1. The child is gone completely. Its reference count is essentially 0, so it was cleaned up. And then once you have the situation where the parent's reference count is 1, you can let it go out of scope or set it to nil, and it will also be cleaned up appropriately, and you don't have any memory leaking. So that's how you can deal with this specific situation. It's not a super common thing. It really depends on how you're designing your applications, but it's an important thing to think about when you are designing your stuff. And Juiced here is asking, can you use a destructor to help clean this up? And it's possible, depending on your overall structure of your application. It could be possible that you could have a destructor on the parent so that when it's going away, it checks if it has any children and clears them. So that could be a possible design that could work. It probably would work for this particular simple thing I have right here. But again, it'll depend on what your specific implementation is. All right, let's talk a little bit about interfaces. These are a pretty cool thing that you can deal with your classes that is not heavily used, but can solve some problems in pretty neat ways. And essentially, an interface is an agreement of methods that a class will implement. Now, when you create your interface, all you're doing is defining the method declarations. You don't actually put any code in an interface. It doesn't have any code. There's no way to put any code. You're just declaring the agreement. This is what anything that uses this interface is going to agree to implement. The classes are said to implement these interfaces. And a class can implement as many interfaces as you want to stick on it. So unlike inheritance, where a class can only inherit from one superclass, a class can implement as many interfaces as you need. Most of your classes probably don't have any interfaces on them, but you can certainly have 1 or 100 interfaces on there, whatever works for your design. And you set these up using the interfaces window. So let's look at the animal example that we talked about in our last OOP 101 example, where we showed how to create a little set of animal classes. And this is how you can do that example using interfaces. So you can see right here, this is what an interface looks like in the navigator. It's got a slightly different icon. And I can expand it. And you can see that it has methods on here. And then the method declaration. I cannot click in this code editor and write any code or anything. I can only specify the method declaration. So what I have here is an interface that I'm going to call animal. And it has a method called speak. Now I have 2 other classes here, cat and dog. And these are not directly related to each other in any specific way other than they both implement the animal interface. And you implement interfaces by, in the inspector for the class, you click the interfaces button. And you'll get a list of all the interfaces that are in your project, and you can just check the ones that you want this class to implement. So you can see here I have animal checked. And when you do that, it's going to automatically add the methods that are in the interface. It's going to automatically add them to the class for you. And that's pretty handy, so you don't have to go and remember what they all are and jump around or anything. They're all going to just show up there. They'll be empty, of course, but they'll all be added for you automatically. So then I can expand the class, and I can see the method here. And I can implement it. Because it was added automatically, it puts this little comment at the top to tell you where it actually came from. And then I can put my simple 1 line of code here that returns what a cat says, and the similar thing for the dog. Now, how is this used? Well, if we go to our window button, because these things are interfaces, and because an interface is actually considered a type, I can create an array using the interface name as its type. So this says that this array can contain anything that implements the animal interface. I could add a window, add the animal interface to window, and I'd be able to add a window to this array. So the array would contain 2 classes and a window. Generally speaking, those things aren't very tightly related, but that's the sort of thing that an interface can do. In this particular case, I am then adding to the array a new cat and a new dog. So an instance of a cat and an instance of a dog. And they, again, are able to be added to the array because they implement the animal interface. Then I can just loop through the array, and I can call the speak method. Now notice I'm calling the speak method here by using a as animal. So I'm calling the speak method on animal. Now if cat or dog had their own methods on there that were not part of the interface, I would not be able to call them because they're not on animal. But because we're dealing with animal, and animal has a speak method that anything that implements it has agreed to implement, we can call it. And by calling it, it calls the methods that we've actually implemented. So when you run this, you'll see that the cat one, which is first, does the meow, and then the dog does its woof. Now it's a pretty simple example of how an interface can be pretty useful. You'll notice when you actually, as you're going through the Xojo framework and learning it, that there's a few interfaces in there. A couple that are probably the most prominent are the readable and the writable interfaces that are used by some of the binary streams. And they provide common methods like read and write. And interfaces are an important thing to think about when you're designing your object-oriented classes or whatnot, because sometimes you may run into a situation where you can't do what you want just by doing inheritance because it's single, one super and one child. And so inheritance can be a different way to think about a problem. And very handy. I definitely recommend you consider using that when appropriate. Let's see here. I got a question from Marcus. He's asking, going back to the constructors, and I presume this is related to the UI code, so let's just quickly do this very briefly here. So if you created your own subclass of a UI control, and you add your own constructor to it, you can see it already added the super constructor for you. Very handy. But you don't want to remove this line, and all your code should go after it, because you want to call the built-in framework setup code before you do your own code. And the other thing to know when you're doing this sort of thing is that if you do initialize properties or stuff here, there is a chance that they could get overridden if the user specifies their own in the inspector. So generally speaking, if you're initializing UI controls, you're probably going to just want to stick using the open event handler. But there are times when the constructor is a little handier than the open event handler, so it can be used as long as you remember those caveats. All right, now we're going to talk about some advanced features that are in Xojo that work in conjunction with classes. So they're kind of grouped here under object-oriented programming. And these are all pretty neat things that can be handy when you're designing your class and your structure of your application. So we're going to go through some examples of each of these and see how they can be used in your applications. So the first neat thing you can do is this concept of assigning a value to a method. So this allows you to create a method that you can use with syntax that is like a property. So you can see here, you could write my method equals value instead of writing my method and then value in parentheses. Now this is simply a syntactical change. It doesn't affect how anything runs under the hood or anything like that. It's a different way to specify your method parameter and then a different way to write your code. It does have a couple subtle things that can help and might be why you'd want to use it when you're designing your classes. And the first thing is that methods can be overridden in subclasses. Properties cannot. So if you actually want something to be used like a property, but you do want to provide the ability for it to be overridden in a subclass, using this particular technique has some value. The other thing is that methods are not shown in the debugger. Properties are shown in the debugger. So if you did use this technique, you wouldn't be able to actually inspect the value in the debugger. That may be good, may be bad, but it's something to consider between the two specific techniques. Let's take a quick look at how that looks here. So you can see this particular example here. We're just creating a new instance of person, and it looks like we're assigning Tim to the name property. But if we actually look at the person class, we can see here that name is listed as a method, not a property. And when I click on it, you can see how the parameters is slightly tweaked here by using this keyword here called assigns. And this is the only little piece of magic here that changes how the syntax works. But it's essentially saying use the value that's coming in the along with the equal statement rather than passing it in using parentheses as you might expect a normal parameter. So in effect, it's more similar to probably a computed property than anything else. And then when you do that assignment, the code in your method gets called. So when we run this, this actually displays the name that got assigned to the method. Perhaps an underused feature, but again, can be very handy in certain situations. All right, the next thing that you can do in Xojo that's pretty darn neat is something called operator overloading. And this allows you to take the various operators that can be used in Xojo, things like plus, minus, comparisons, multiplication, division, and there's a whole list of them available on this page in the language reference. And it allows you to define how they're used with your classes. So for example, well, we'll look at an example here. But normally, doing things like plus or minus on a class does not make a heck of a lot of sense. This example here is going to show you how you might make a class that can be compared to other instances of the same class. So for example, we created two instances of person here with two names. We want to compare them. Well, if we look at the compare method here, we're just checking if the first instance is greater than the second instance. Well, what does that mean? These are classes. What does it mean to compare the first instance to the greater instance, to the second instance? Well, if you just run it as is, here it's telling you that Picard John Luke is greater than Draper, Don. Well, alphabetically, that doesn't, I guess that does make sense. Alphabetically, P is greater than D. But this one here doesn't seem to make much sense, as those two appear to be equal. So because you're defining your own comparison, you can define how you're comparing classes. Now in this particular person class, I can define that, well, it probably makes sense to do the comparison based on the name. It could be anything. I could decide to do the comparison based on their address or their location or whatever I decide because I'm the one implementing it. So if you look down at person, you can see here there is a method called operator compare that I've added an X to the end, so it didn't get run before. But when you call it with the right name, operator compare, it gets run whenever the comparison operator is used with your class. And it passes in whatever's on the right-hand side, and it's also going to be passed in as a person. And then you can do the comparison on whatever it is you want to compare. So here I'm just comparing a property that I call compare name, which just happens to be a computed property that's just doing the last name, comma, first name. And I'm just comparing that because you can compare strings. That's comparisons between strings is clearly defined. So I'm comparing the strings of the names of the properties that are in the class and then returning specific values if one is greater than the other or if they're equal. And then you can get the measurements, the comparisons you expect, and actually do something useful with it. This would allow you to, more easily perhaps implement sorting on an array of these persons, for example. There's equivalent operator underscore methods that you can add to your classes for, like I mentioned earlier, all the different operators that are in the Xojo language. Generally speaking, only a few of them are going to make sense for most classes. For example, it wouldn't make much sense to implement, say, operator subtract on a person class. What would it realistically mean to say P1 minus P2? That might not be something that you can clearly define to make much sense. Maybe adding them might make sense. Don't know. Depends on your rules for how your classes need to work, whatnot. But if you were implementing your own math type classes that were handling more advanced math concepts, you might implement some of the other math functions. So again, lots of them that are available on that page, and you certainly can take a look at that. I just added this page today to kind of group all these together more easily. I believe they're also listed in the user guide as well. I have a question here from Just asking, what's the advantage of assigning values to methods, I'm going to presume, over using a computed property? And the advantage is essentially what I mentioned regarding the difference in overriding. You cannot override properties on subclasses, but you can override methods. So that is one advantage depending on how you want to design your classes. And the other difference, whether it's an advantage or not, remains to be seen, but computed properties will display in the debugger. Method assignments do not. All right, another one that's somewhat related to operator overloading is operator lookup. And this allows you to write dot notation that does not refer to actual properties or methods. Kind of weird. Essentially, it's almost a form of dynamic programming, if you will. It's built into Xojo. And these dot notation commands that you type that don't actually refer to real properties or methods get sent to a lookup method that you can then parse and do with however you want. So let's take a look at that example. All right, so again, creating a new person. Looks like here I'm assigning a value to an address property and to a city property. But when I run, you'll see I get two errors. These two properties don't exist. And if we go look at the person class, expand these out, you can see absolutely they do not exist. There's no address or city anywhere on here. There is this operator lookup X function that I am now going to give the correct name. And you can see what it is doing in the code here. It's checking if address was supplied as the dot notation name. And if it was, it's going to display the value that was assigned to it. Otherwise, it's just going to display a message box that says, hey, that particular dot notation is not supported. So now when I run, there'll be no compile error. And when I actually run the code, it's displaying what was assigned to our fake property, if you will. And then the second one is getting the unsupported lookup because we only have a check here for address, yet we also have city on here. Now this has the downside of, I can type, well, it's going to start, but I can type whatever I want here. And I'm not going to get a compile error. Well, I will if I don't use the right syntax. And you'll see I get the address one that I've actually implemented. I get unsupported for the city, and I get unsupported for my gibberish that I typed. But it does prevent you from getting compile errors on what are obviously things that don't exist on the class just yet. So again, there's very specific situations where this can come in handy, but it is a pretty powerful technique. And you can implement this a variety of ways. I implemented this version of operator lookup to take in a string. So the name that comes in is always going to be a string, but what the assignment or whatever the other parameter is that you want can be anything. And here I've set it up as a string so that we could do assignments like this. But you could, use integers or whatever other types you want to use to set it up however this proves useful for you. But it's a very powerful feature that can have some uses. And again, it's kind of being able to do something like this is pretty slick. I've used it myself in database access. If I have a class that refers to a database table, I can just type the column name after here, and I can at runtime look up specifically what the column is on the database table and get the value I need without having to implement a bunch of classes, a bunch of properties or methods in the class that map to all the particular column names. So that's one example where that can come in handy. But definitely a feature that's not heavily used and perhaps a lot of people don't know about. All right, before we continue, I am going to run our fun little polls that we run every week. So let me do this here. Start the first poll. I'll run them for about 30 seconds each, so it'll only take a couple minutes. There's 4. And this poll is, what type of apps do you primarily create with Xojo, desktop or web apps? All right, thank you. And the next one is, do you have a Xojo Pro license? All right, great. Good fast poll voters here today. Let's go a little quicker. How long have you been using Xojo? And our last poll question, how do you use Xojo? You can check multiple ones on this particular one. All right, great. Thank you, everyone. All right, the next thing that is available for use with classes is something called attributes. Now, generally speaking, attributes are used with introspection. Now, we're not going to go over introspection today. That's a topic that could probably be covered by multiple webinars, and I think I do. It's not on the schedule yet, but I expect to have an introspection webinar in the September timeframe. So generally, attributes are used with introspection, and they're little tags, if you will, that you can assign to your classes or things within your classes that can be looked up at runtime. But there are 2 special attributes you can use without introspection that can control how your classes and methods are identified by the IDE, by Xojo itself. And those are called deprecated and hidden. Let's take a quick peek at these two. All right, so here, again, same sort of thing, creating a new instance, and I'm assigning some values to these two properties. But if you look at those two properties, you can see there's a little A next to them here. That little indicator means that there's an attribute, one or more attributes, assigned to these items. So if I click on it, attributes are in the advanced tab of the inspector. So I can click there. And in the attribute section, I can see there's an attribute on here called deprecated with a value of full name. Now this means that this first name property I've defined as being deprecated, and the user should instead use the full name property, which is a new property I've added here. And the same thing for the last name property. I also deprecated it and said use the full name property instead. Now this won't affect compilation or anything like that. Just like with anything else that's deprecated, you can still use it, but it does have a couple side effects. First, these things don't appear in code completion. So if I were typing, you can see first name is not a choice because it's deprecated and you want to encourage the user to use the property name that's actually available. And also, if you do analyze your project to check for warnings and errors or whatnot, you can see that there's a warning here that says deprecated items have a replacement. If we make it a little bit bigger, you can see our lines of code here. They're marked with the little yellow triangle. And the message says that the property you're using, last name is deprecated, you should use the full name property instead. So particularly if you're designing classes that are used by others, or you have classes that you're selling, or just an API in general that you're creating, this can be a great way for you to identify techniques that you no longer want people to be using because you have a newer, better, improved one in place. Now it doesn't affect how the code runs. If I want to run it, the items are still available. So the code still works as you would expect. The other hidden property, you see right here, I put on the hidden method because it has an attribute. And it is simply just the name hidden. And that hides that method from code completion. That's all it does. So if I try to type, you can see there's no code completion on that. Only the items that are there are available. However, if I do happen to know the name for some reason or another, I can use it. And I will not get a compilation error because the method actually does exist. But again, if you're designing code for others to use, this can be a good way to mark methods that you don't want them using. Maybe you, for some reason, are not able to make them private because they do need to be called by other code that's in the know, but you don't want general purpose usage to be calling a particular method. So these two little attributes are kind of built in, have some special features. But of course, you can add your own attributes. You just hit the plus button and type whatever you want as the, let's come on to here. So for example, in example one, say this was mapped to a database table. You might have an attribute here called table name, and maybe your table structure is something like this. So you could have an attribute created like this, and then in conjunction with introspection at runtime, you could look up this attribute and find the actual table in the database that you're supposed to be interfacing with. So that's the general, one of the ways you can use attributes in conjunction with introspection. Juiced is also pointing out that these sort of things can be used for unit testing. Yeah, oh yeah, they can be used for lots of things that work in conjunction with introspection. By themselves, they're not really terribly useful other than the deprecated and hidden attributes. They're a pretty advanced feature, but again, can be pretty handy when you need to do something that you have no other obvious way to do. All right, the next thing we're going to talk about is casting. And this is the concept of making a type more specific. Now, when you have interfaces or inheritance, your instances can have essentially different types. It can be its type itself, or it could be the type of the superclass. And sometimes you may use the superclass type to pass things around in your application because it's more generic and can hold more things, more types of things. But on the other hand, there may be situations where you need to get at specific information that's only in a subclass. And if it's not in the superclass, you won't be able to access it if it's a property that's only in the subclass. So you have to cast this thing down to the more specific type. So let's look at an example. All right, so we're got one extra class here, royalty. And royalty is a subclass of person. So we created a person, set them up, created a royalty. Royalty has a new property called title. So here we've added Elsa, the Snow Queen. Now we can assign our empty person here the royalty person. And that works because royalty is a person. So that assignment works just fine. But now if I want to actually get the title of the royalty that I've stuck into this person object, I'm going to get a compilation error because person does not have a title property. And you can see right here, you get the item does not exist because P is a person. Person does not have a title property that we can access. But we already said that royalty is a person. And because P is containing a royalty, we can use the more specific type. We can cast it to royalty. And you do that just by putting the more specific type that you want, and in the parentheses after it, giving it the value you have. And then now you can access the title property. So if we comment out our line that doesn't work here, see the code will run, and here it will show the title. Now this is all in one line. I could have also, written this as or we could have done and then you could just use R2. Any way you want, accessing all the specific values associated with it. Now, even if you don't have a particular design in your application where you're making use of this thing by passing around superclasses, this can be handy when used in conjunction with variants, particularly when you're, say, storing objects on row tags of variants. When you get the value back, you're going to get back a variant, and you're often going to want to do this same technique to cast it to its appropriate type so that you can access all the properties and methods that you would expect to be able to access. But this is the general technique, and it's important to remember that this is just saying to use a more specific type. It can't change the type of anything. I couldn't just take a value here and say, oh, well, I want to convert this to be a type of some other class. That's not going to work. It just, well, even if this did work, so let's see if we went like that, you're going to get an error, at runtime. And it's telling you that you illegally cast, it doesn't convert things for you, and it only casts things by making them more specific. So this is completely illegal. It gets you a runtime error. Your app terminates, and all that bad stuff. So you don't want to be thinking about doing that sort of thing, which sometimes people might forget and their specific relationships and just try something like that, and that's the sort of thing you're going to run into. All right, static variables. Static variables are essentially global variables that have local method scope. Again, a specific need for these sort of things, but it means that the variable is going to retain its value the next time the method's called, which is a bit unusual. I mean, generally speaking, variables are local to methods. They're, when you call the method again, the variables are all reinitialized. But if you declare a variable as static, its value is retained. So let's take a quick look at an example. So rather than using dim, I have the static keyword here, and I've just created a variable I'm calling count, and then I increment it. Now, if we used dim, each time you'd run this, count would be 0, because that's the default value of an integer. Incrementing at the end would have no effect. Well, we would increment it, but we would never see that because the method would terminate. But here, when I run this, first time it's going to be 0, that's the default value. But it's going to keep remembering the value, so it's going to keep increasing. Now, I can't access this count variable anywhere else. If I create another method on the window here, count is not going to be available to me because it is scoped locally to this particular event handler. But its value is retained. And this sort of thing can be useful, again, in specific situations. If you had a value that was expensive to initialize, you may declare it as a static, so essentially that initialization only happens the first time. And it can be useful just for tracking things that otherwise you maybe would need a property for, or something a little more global to track. Again, it's a specific fine-tune type of thing, but it can have its uses when you run into them. All right, the last thing I'm going to cover today is shared properties and methods. And these are properties and methods that you can access without an instance of your class. In some of the programming languages, they're actually called class properties and class methods. But in Xojo, they're called shared. And let's take a look at how those are set up. All right, we'll go back to our person class right here. And you can see usual methods. Here we just have the constructor, usual properties. These can also be referred to as instance methods or instance properties because you need an instance to be able to use them. But also shared methods and shared properties are here. And you can add those just to here. They're kind of at the bottom here. And you've got the 3 different kinds: shared computed, shared methods, and shared properties. And when it's shared, it means you call it by using the class name. So just person, and not a specific instance of person. And what can they do? Well, they can do, you can put code in them. They can do what they want. They cannot access instance methods or properties. So I cannot access the first name property here because unless I create, my own instance in the code, and then I could access it as, p.name, a p.first name. But I couldn't just here write first name equals this. That's not going to work because first name is an instance property, and it doesn't make much sense to access that if you don't have an instance. What this particular shared method is doing is saying, all right, well, just give me a default person, the token generic John Smith, and return that. And it's called like this, just using the class name and then calling the shared method. And this is returning an actual person instance. This returns a person instance. So then it can be used just as if you had created it using new person yourself. This sort of thing is sometimes called a factory method because it's creating instances for you by a method, and can be very handy for quick ways to get information back without providing a lot of setup. A default person by itself doesn't make much sense, but certainly other classes can have defaults that might make sense to get back in this particular way. Similarly defined down here is a count property that's defined as a shared property. And that everything is still the same, just the count and its type or whatnot. But this is used as a way to track instances that are created of the person. So each time a new person is created, and I have this in both of the constructors, I just increment the count. This is just telling you total instances. If I wanted to actually have not total instances, but total instances ever created. If I wanted this to be perhaps more accurate, I would probably want to add a destructor, and I would reduce count whenever an object goes away. And this would essentially allow me to track how many times these things have been created. So when you run this, you can see we got the last name of our default, and then we've got our count, which appears to be zero based. So oh no, sorry, it is not zero based. It is since I'm reusing the same variable, the old one went out of scope. So 1 is the correct number since I added my little destructor there. But if I actually keep 2 alive and I declare it, the count will get returned as 2. So that is how you can use shared method as properties. These also very handy. Do consider and remember that they are there. All right, that was the last topic. Like the last webinar, we are giving away a copy of OOP Demystified by James Keogh, I guess. I'm not entirely sure how to pronounce that. After the webinar, I'll be collecting all the names of the attendees, throwing that in our random name picker app-ish thing, and someone will be notified in the next day and get a copy of this book, which covers all kinds of object-oriented topics, generally, all of which do apply to Xojo. So very handy. Now, somewhat little note of webinar schedule. This OOP 101 webinar was actually in June, but unfortunately the recording didn't work so well and was lost. So I'm repeating the OOP 101 webinar next week. Unfortunately, it looks like we're doing 201 before 101, but that's just kind of a scheduling snafu. But But this recording looks like it's going just fine. I'm hopeful that it saves properly. And then next week we will do the 101, the OOP 101 webinar again, so that we can get a clean recording and then have both 101 and 201 available for people to rewatch on YouTube. And speaking of webinars, I will point everyone to our webinar page here on the Xojo website. And here are the registration links for all the upcoming webinars that are on the schedule, including next week's 101. I'm also repeating the databases webinar, which had recording trouble as well. And we have another webinar and then yet another repeat of a webinar that had recording trouble. Hopefully that's the end of our recording trouble. I think we've pinpointed what the difficulties were, and I believe the GoToWebinar people have also done an update which should help us with that. And then we've got a few more into September and others that are pending and waiting to be added to the schedule. So certainly register so you can reserve your spot. These have been known to get full. And as I did post on the forum, I want to certainly ask of people, if you are an expert in something or just like chatting and have a topic you'd like to discuss at one of these webinars, by all means, I love having guest presenters. It saves my voice, right? So by all means, get in touch with me if there's something you might want to talk about that doesn't have to be specifically Xojo related, but certainly technological and applicable to Xojo. And we love to have a wide variety of topics. So if you have something that you think would be appropriate, do touch base. And I got one question here from Juice that's asking if he can ask questions that we can be answered in future webinars. And certainly I suppose so. I mean, you're always welcome to shoot me an email, ask a question, suggest a webinar. All those things go on my list and are reviewed when we put together upcoming schedules. So yeah, by all means. Most of these webinar topics are a result of feedback and questions I've gotten from people. So keep sending me that. All right. Thank you everyone for attending. Have a great rest of your day.